Hello again and welcome to MathTablet. In this session of the coordinate geometry series, we're having a look at the equation of the line. Now the equation of the line is often given as y equals mx plus c. This is referred to as the gradient intercept form of the equation of the line. The m here represents the gradient of that line, and the c value here represents the place where the line crosses the y-axis, so often it is called the y-intercept. The values of x and y here represent any set of coordinates x and y such that that point belongs to the line. Okay, so let's have a look at the typical sort of question that comes up in this sort of context. Let's just do a quick little example here. Suppose we asked what is the gradient and y-intercept of the line, let's see, something like y equals negative x plus 9. Okay? Now, in this case, we need to pull out the m value and the c value. Fairly easy to see that your c value here is 9, which means that the line is going to cut the y-axis at the point 0, 9. Okay, your m value here should be the coefficient of x. Now at the moment it's just got negative x, so we have to think of this as negative 1x, right? Which means that the gradient m is going to be equal to negative 1 in this case. Alright, let's have a look at another one. Suppose you've got something like let's see, 2y equals x minus 2. Okay. Notice that in this equation here, it doesn't fit that form of y equals mx plus c because we've got a 2y in the front. So what we do in this sort of question is to make it fit the form y equals mx plus c. So to get the y on its own, I would divide through by 2. So what I'm going to do is divide the whole equation through by 2 so that I get the y on its own. So instead of x, I would have half of x. Okay, instead of negative 2, I would have negative 1. This now is in the form y equals mx plus c, so I just need to pull out the m value as well as the c value. So in this question, the gradient would be a half, and your c value is going to be negative 1, which means the line is going to cut the y-axis at the point 0, negative 1. Okay, let's try one more. Something like 3x plus 3y equals negative 5. Okay, so again we would have to rearrange this equation to make it fit the form y equals mx plus c. So let's subtract 3x from both sides first. So I'm left with 3y on the left hand side, and on the right hand side I've got negative 3x subtract 5. Okay, now I need to divide both sides through by 3. So y would have to be negative 3 divided by 3 is going to be negative 1, so it's negative x. Okay, and then negative 5 divided by 3 will be negative 5/3. Right? So again, remember this is like a magic 1 here that has appeared. Your gradient of this line is going to be negative 1. And your c value is negative 5/3, which means that your graph will cut the y-axis at 0, negative 5/3. Okay, now let's have a look at another example. So sometimes we get something like this. What is the equation of the line which has a gradient of, say, -3/4 and cuts the y-axis at 0, -1. Okay, so just from the question you can identify your gradient, which is going to be -3/4, and the y-coordinate there tells you your c value is -1, which means that the equation y equals mx plus c will become y equals -3/4 x take 1, just by substituting in those values of m and c. And we could rewrite this as y equals -3x/4, just to combine that as well. So that would be the equation of the line. Let's have a look at one more example. Suppose we are, say, what is the equation of the line with gradient of, what shall we pick, 3/2, and passes through a certain point. So passes through the point -1, 4. Okay, so in this question, because we've got the gradient, we can say y equals mx plus c, in this case must be y equals 3x/2 plus c. Right? But we don't have the c value because we're not told what the y-intercept is. However, we are told one point that belongs to the line. Now remember, in the form y equals mx plus c, the x and the y represent any point that belongs on the line. Okay, so to work out the value of c, in other words to find the equation of the line, I would substitute my x-coordinate here of -1 and my y-coordinate here of 4 into this equation of the line that I've got. So instead of y I would have 4, and then instead of x I would have -1, so it'll be -3/2 plus c. This equation now can be solved to find out what that value of c is. Okay, so let's see, if I excuse me, if I were to find that value of c, I need to add 3/2 to both sides. Okay, so it's going to be 4 plus 3/2 will give me the value of c. So that's what, 8/2 plus 3/2, which is going to be 11/2 for the value of c. Therefore, my equation will be y equals 3x/2 plus 11/2. Now, some people would rewrite the same equation but without the fractions. So if you can multiply everything through by 2, you will get 2y equals 3x plus 11, which is also the equation of that same line, but it looks a little bit neater sometimes without the fractions. Let's have a look at one more example of finding the equation of the line. So suppose we've got something like this. Find the equation of the line that passes through 2 points. So let's say 3, 7 and 5, 1. Alright, so in this question we need to find the equation of the line, but we only know 2 points that belong to the line, right? So we know that our final answer needs to look something like y equals mx plus c. We certainly don't know what c is because we don't know where the line is going to cross over the y-axis. We could find out what m is though. In an earlier session we looked at this formula for finding the gradient, y2 minus y1 over x2 minus x1. And what we're going to do is to use the same formula to find out what the gradient is in order to find the equation of the line. So that's going to be my x1, y1. That's going to be my x2, y2. So the gradient then would be 1 minus 7 over 5 minus 3. So that's going to be negative 6 over 2 or negative 3. Okay, so from here I can say my equation of the line must look like y equals negative 3x plus c. So basically I've now got the gradient for that equation of the line. Okay. Now in that previous example we basically excuse me, started off at this point where we knew what the gradient was but we didn't know what the value of c was, and what we did was we substituted one point that belongs to the line into the equation so that we could find out what c is. Now we're going to do the same thing in this case. Okay, doesn't matter which point you substitute in. So let's say I were to pick, I don't know, 5, 1 to substitute in here. So instead of the y I've now got 1, and instead of the x I've now got 5. So it's going to be negative 15 there plus c. To get the c value I now add 15 to both sides. Okay, so my c value will work out to be 16. So now that I've got my m value and my c value, I can give the equation of the line. So my answer would be y equals negative 3x plus 16. Okay, some people may write that as y equals 16 minus 3x, just so that that first term is not negative, but it's still the same equation. I hope you have enjoyed the session of the Math Tablet.